So we're going to start up with the first session of microservices architecture. The starting point for most microservice architecture is typically the rationale as to why one, you know, decides or wants to move into microservice architecture. And in 9 out of 10 scenarios, when we kind of moving to monolith, to microservice architecture, we typically dealing with monoliths. So here, this session, we are focusing completely on what is a monolith, what is the advantage and the disadvantage of monoliths, and eventually how does microservices attempt to solve the problem from a monolith standpoint of view. Now, typically, if you see the architecture in the past decade, a lot of it has actually moved from a N-tier, three-tier architecture standpoint. In the last 5 to 6 years, we've seen more architecture which evolved. Now, architectures generally, patterns which are generally evolved are typically what we've seen are very closely coupled to what happens from an industry, tech industry innovation standpoint of view. So in the last 5 to 7 years, we've seen most application are kind of catering to multiple UI devices. Now, it could be a web-based application, it could be a mobile application, it could be an IoT device-based application, which is forming as an input. So we're seeing a lot of form factors kind of evolve in the past 5 to 7 years, and at the same time, most of the application that you build generally is kind of dependent on a lot of different external services. Now, external services can be, the database, it could be email, it could be other APIs in general. So, what's really evolving at this point of time is you on the left hand side you have a lot of UI based elements which are actually coming, and on the right hand side we see a lot of services. In the center, all of this we generally that's where the application logic and the application layer kind of resides. So this kind of gives you the construct of what an hexagonal architecture is, and the right hand side is talking in terms of more of an implementation standpoint of view. Now there are typical signatures from a hexagonal architecture standpoint of view. Now the core application module consists of collection of domain objects. So typically what sits in the center is going to be all the domain objects and everything which is related to your business, order management, delivery management, billing and payments, and the surrounding business logics, are various adapters like we kind of talked about. The inbound adapters typically implement the UI, the outbound integration, integrate with external system like the database or other services in terms of Twilio and Stripe. Now, however, there's one key thing which you should really check in any hexagonal or logically modular architecture. Now, the question which you should be asking yourself is my application package as a single deployment file. Now, obviously, the people have been using monolith since quite some time, quite a number of decades. There were obviously some advantages. Now, what the advantages typically what we've seen is that you start off small, you have your deployment file which is fairly small. Typically, it's simple to deploy. Your IDs and other developers are focused on a single application file. Anything which changes in an application file, it's very easy to kind of change the application file and deploy, because at the end of the day, it's a single file. Straightforward to test and deploy, easy to scale, run. So typically, when you're scaling, you end up running multiple instances of the application behind a load balancer. Now, over a period of time, what happens? The development, testing, and deployment becomes very difficult because your size of your file becomes extremely large, because over a period there's a lot of functionality which keeps getting added. So what we really resulted, it's like we outgrow monoliths in over a period of time. Larger code base, and then what happens is the multiple scrum teams. So typically now your core business logic could be dealt with one team, your inbound adapters could be dealt by another, and outbound adapters could be dealt with another. So in a situation like that, you're obviously going to have multiple teams. Now, the more than the number of multiple teams, the dependencies across each one of them becomes too high. The kind of tight coupling now. If an outbound adaptive team decides to make a change in the code, then obviously you have to basically make one big large deployment. So the overall development becomes very slow because of the dependency. Larger code base, increased complexity, more bugs leading to missed deadlines. Scaling becomes absolutely impossible because you're seeing that your code base is very large, functionalities are there. Now there could be a reason where your outbound adapters would want to be scaled better. Not you don't need to basically kind of go ahead and deploy, and scale the entire application now. But given the inherent nature is a single application file, there are chances where you're going to be scaling the entire application. Application reliability really becomes the question mark. Now, locked into increased obsolete technology stack. So typically, if you really see monolith architectures across the board, you would have used one tech stack, and now you would want to kind of try out, adopt new frameworks and languages. It's just not possible because it's a single deployment file. It's kind of, it's kind of tightly coupled with the same, platform or the framework or language which you kind of pick. So these are some of the drawbacks which we've seen in monoliths which actually happen over time. Now, typically, what happens, you are when monoliths we generally see we are marching towards hell. We see the large development organization. We see a single code base create communication, and coordinating overheads. And then we obviously large, complex, unreliable, and difficult to maintain. So over a period of time, it just becomes impossible because the example which we choose now, in this case, we have an order management team, we have a restaurant management team, and a delivery team. Now, all of them are kind of pushing, the code base to a same source code repository, and then you have the pipeline, which does the Jenkins CI backlog, the manual testing, and the part from the code commit, becomes the production is arduous. Now, changes sit in a single queue until they've been manually tested. So obviously, this over a period of time, your team slow down, and your application reliability is a question mark. There are a lot of different areas which you start seeing problems, and eventually it leads to a point where the slow march towards monolithic. Now, typically when you're scaling monoliths, now there are some methods which you will actually come. One, so you probably will take the XYZ scaling. So in case of x-axis scaling, you're probably going to do you're going to run many instances of the same application. Typically, in the Z part of the scaling, you probably will try to run multiple instances. You'll probably come arrive at some breakdown of the instances in terms of the first instance may deal with the customer ID from 1 to 100, and the second one would eventually deal to 100 to 200, and so on. And the third one probably is a slightly different one, which we'll talk a little bit more in terms of, basically scaling by functional decomposition. Now, these are the common methods which you generally, the x-axis can be talked as a common way of scaling by running multiple instances of the application behind a load balancer. Now, the z-axis is typically where you would define your, the identical application instances, specifically in case from the application instance uses A to H, I to P, and uses R to Z, and where each instance is responsible to a subset of the users. Uh, just a minute. So typically common methods of scaling in an application. We kind of talk to the X and Z axis of scaling. I mean, that's something we've been using predominantly for quite some time. Now, when it comes to Y-axis scaling, it's mostly around functional decomposition. That is ideally breaking down your business entities or objects or functionality, in terms of functional decomposition, or you may end up using some kind of segregation at a business functionality level to kind of achieve that functional decomposition. So y-axis scaling splits the application into a set of services. Now, each service is kind of responsible for a particular function. Now, the idea is really in terms of going identifying the right services is very important. A service is scaled using the x-axis scaling and possibly y-axis after that. A service is a mini application that implements narrowly focused functionality. A service is scaled using x-axis or z-axis, but ideally, the whole idea here is that you need to first kind of break down your application in terms of different services. Now, y-axis is all about scaling functionality, decomposing an application into services, and then eventually applying your X or Z type of scaling based on the requirement. Now, this is exactly what microservices is all about. So, what we are kind of arriving from the function decomposition is a clear-cut set of services, which we eventually kind of call microservices. Now, So basic from a definition standpoint of view, an architecture that functionally decomposes an application into a set of services where each service has a focused, cohesive set of responsibility. Now, applications must be decomposed into modules. Service becomes your basic unit of modularity out here. Services have an API and which is impermeable boundary and difficult to violate. And generally, services will end up having a query or a command. A query will be typically in terms of the retrieval of data. Command will be the standard commands which you issue on service at the API level. Services then eventually kind of go ahead to be very easily deployable and scalable because they are kind of segregated. And each service may have its own database, and this isolation helps in schema changes or service changes. This typically looks like what a microservices pattern architectures look like. It's kind of derived, the whole intuition is taken from the hexagonal based architecture, and then eventually taking it one step further and breaking down into the different services. You're actually seeing on the left hand side, which is predominantly the area where the inbound adapters, typically your API gateway, your restaurant web APIs, which is kind of shown on this, the REST-based API, all the inbound adapters come onto the left-hand side. On the right-hand side, you typically see the outbound adapter because your functionality is eventually going to talk to a lot of outbound services. Now, that could be, in terms of, let's say, a messaging service, and in this case, is Amazon SES adapter, Twilio adapter, and a Stripe adapter. And in the center, you pretty much have all your core business functionality, which is eventually the services corresponding to business capability. Domain driven design and subdomain, that is a session which we're going to be covering later, which is in terms of how do we kind of do a functional decomposition, how do we really arrive at service. It's essentially really an art. I mean, there's really no science, but once we kind of get there, we'll kind of talk more to it. Now the very basic question which idly kind of comes up, since people who've been in the industry, the typical questions like, hey, okay, microservices there, what's the big deal, because we already had SOA. Now SOA typically solved a very, very specific problem. Now, if you really look at SOA, they're typically around the part where they are dealing with larger monolithic based application. They have data which is kind of share, global data and share data model both. And eventually, the pipes are really smart pipes, ESP, heavy lifting pipes, heavyweight pipes, protocols such as SOAP and web service. When you really look at microservices, these essentially are dumb pipes, and they're kind of message brokers, direct service communication, lightweight communication protocols such as REST and gRPC. Data model is ideally going to be per database per service. And eventually we have a smaller application. That's where the SOA services really kind of come. Obviously, like microservices, like any other architecture pattern, has its benefits and it has its drawback. Typically, when you're looking at benefits, as you kind of understand that kind of enables continuous delivery and deployment of large complex applications. Services are small, easily maintainable, services are independent, deployable, and scalable. Teams become autonomous, allows experimenting new technology and better port isolation. A drawback? Yeah, there has to be some drawback. Finding the right set of services is a challenge. Distributed systems are complex, which makes the development and deployment difficult. But there is a narrative around in terms of how to kind of manage these things. So, I mean, there's a separate session which kind of talks to, how to really handle distributed systems when it comes to microservices. Deploying features that span multiple services requires careful coordination. Adopting a microservices based architecture is really not straightforward. It's not just like a new vocabulary in town. I just need to kind of go get microservices and I'm going to change my architecture overnight. There is a lot of thought process, a lot of assessment, a lot of inventory checks, and eventually kind of looking through various tenants of microservices. How does a fitment really happen? And then you kind of take a call in terms of, hey, do I really need microservices or am I good to go with what I have? I mean, so that's a question which you really need to ask.